Pressed it.
Pressed it? All right. Okay. Sorry about that. We had dogs running away with dinosaurs and then jumping over fences and all sorts of stuff, but we're back. Okay, so the idea here is, remember, we're trying to find these areas and we're using our calculator to do so. So let's just look at another example. Let's get rid of some of the stuff we have here. So this time I'm going to give you the graph that looks like this.
Yeah, A+.
Remember that this is a z-score. We're not dealing with the regular number line. We're dealing with the z-score number line. 0 will be in the middle. But this time I'm asking you to go from a z equals negative 2.01 to a z equals 0.97. So I'm asking you to go all the way across the middle this time. So lower boundary, Ginger and Max, of negative 2.01 and an upper boundary of 0.97. So you're going to go to your normal CDF and you're going to put negative 2.01, comma, 0.97 and close the parenthesis. Or if you've got the other calculator, you're going to use that as the upper and lower limits. Okay, so again, if you've got this calculator, second distribution, normal CDF, hit enter. Lower boundary is going to be a negative 2.01. Upper boundary is going to be a 0.97. Down, 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 paste, paste. And here I get a 0.8118 if you round. And again, no matter which form your calculator does, the answer should come out the same. So 0.8118. So what it's telling us is that this area here, the area that's shaded in, is 0.8118 or 81.18% of the graph. Now remember, my graph is just a guideline to go by. It's not necessarily to scale or anything, but what we have shaded in here is 81.18% of the graph. And then notice that every time you write this, you want to have either the word area or an A. Don't leave this because in everyday life, do people know what the heck that means? Nobody has any clue. But if you say area, they go, oh, area. Oh, I get that. Okay, the area is 81.18%. Okay. All right, so let's look at another one. So the ones like this one and this one, where we have actually two boundaries like that, those are the easy ones to plug into the calculator. But sometimes we're not so lucky. So this time, this one says find the area to the left of z equals 1.99. So this time they chose to write it out in words, and written out in words, we still need to be able to do this. So honestly, the easiest way to make sure you don't screw this up is to draw yourself a little picture. It only takes a second to draw a picture. Get your z-score where it belongs. So a positive 1.99 would be over to this side of the middle, right? There's 0. So that's our z-score. And they want us to find the area to the left. So left means this way, but it didn't give us any lower boundary. So left means all the way that way, all the way. So including any possible outlier we might have on the lower end. Now the problem is that when you use the normal CDF mode on your calculator, you need that lower boundary, and we don't have one this time. So remember that our z-scores are always kind of between about -3 to +3. So what we want to do is we want to consider what would be way out there. And obviously that would be going towards negative infinity, but we can't plug negative infinity into our calculator. So what we're going to do when we get one of these tails, okay, that's what it's called, a tail, headed off in one direction, we're going to let our lower boundary be negative, and 10,000 would work, okay? If you like 100,000 better, go for 100,000. But negative 10,000 is kind of the norm, okay? So using negative 10,000, because that's definitely way over there, isn't it? So if we use negative 10,000, we should get a pretty good approximation of the answer. So we're gonna go to our normal CDF. For our lower limit, we're gonna put in negative 10,000, comma, our upper limit will be 1.99. We stick that guy into the old calculator, and this time I get an area of 0.9767. So remember that if you're going to be able to do this on a test, or while you're doing your homework and stuff, you need to practice this yourself, because if you forget where this is on the calculator, then you're kind of out of luck. So even though I just wrote the answer right here, make sure that you practice that so that you make sure that you get the correct answer as well. And don't forget the label on there. And don't forget the 4 decimal places, okay? So remember, your answer should look like my answer. If it doesn't, there's a problem. Okay? All right, let's keep it up here. So this one says, find the area to the right of z equals 3.01. So draw yourself that picture again. Z equals 3.01 is maybe about here on the graph. But it wants the area to the right. So that means we're looking at that part of the graph. Now again, this is called a tail. Whenever you're going off into like the outlier section in either direction, that's called a tail. So we're looking for the area of a tail. But again, that's going on and on and on forever and ever. So the difference between that one and this one is that this one's going on and on in the positive direction. So instead of using a boundary of negative 10,000, we're going to use a boundary of positive 10,000 on this one. So again, we've got our normal CDF. Start with 3.01 and this time go to 10,000 and stick that into the old calculator. And when we do, you should get 0.0013. So we're finding that this area is very small, okay, and that should make sense to you, because looking at the whole graph, do we have a small amount shaded? We really do. Look at this one. This area is quite large, 0.9767 or 97%. Now again, my graph's not perfect. But do we have a lot of the graph shaded in on this one? Yes. Little of the graph shaded in, so this number is little. All right, I think just one more here just to practice. All right, so this time they ask you to find this area, and they tell us that this is z equals negative 2.37, and this is a z equal to negative 0.41. Okay, so one more time, try this one in your calculator. Now this time you do have 2 boundaries, so you don't have to use 10,000 or negative 10,000, but I want you to notice they're both negative, so make sure you get both negatives in there. And once you stick that into your calculator, work it out. The hope is that you get an area of 0.3320. All right, so we're learning to use that calculator, that function on the calculator, the normal distribution. Okay, we're not quite done, okay? So we've been able to find these areas. So this area right here is 0.3320, okay? This area right here is 0.0013. But do you think we can go backwards? Okay. So now, let's go backwards. So if I give you an area, can you give me the z-score that bounds it, okay? So if I give you the area, can you find the z-score? Guess that's a question. Here we go. Now, it's not as easy as this was, okay? It's not super hard, but it's not as easy as the normal CDF, okay? So not as easy. And the biggest reason why this is not as easy is because the way the calculator does this is always by giving you a left tail, okay? Left tail. So you need to think left tail, always left tail. So we'll start with a left tail just to see how this works, but then I'm going to show you one that isn't a left tail, and we're going to have to figure out what we need to do here. Okay, so let's say that they gave you a graph, and instead of giving you a z-score along here, so instead of giving you a z, they're going to give you an area. So they're going to shade in a tail there, and they're going to say that this tail, let's see, what is it? 0.10. So if that area is 0.10 or 10%. Now what we want to find is this z-score. What does that z-score equal? Now, you're supposed to think left tail. Well, do we have a left tail? We do. If we have a left tail, life is good. This is very easy to plug into the calculator. Oh, I'll write it here first, then I'll show you on the calculator. So because we're going backwards, we're not going to use the normal CDF. We're going to use the inverse key on the button, or on the calculator. So we're going to go inverse norm. So instead of going normal CDF, we're going inverse norm, and this is going to help us go backwards. And we're going to put in 0.10. Okay. So let me show you where that was. Very similar to what we've been doing. Okay. So you're going second distribution, same place we went before, but instead of going to normal CDF, you're going to slide down one more and see how it says inverse normal. Inverse norm. Click enter. Then either if your calculator just gives you the inverse norm, you put in 0.10 and you close the parenthesis and hit enter. Or in our case, we go 0.10, slide down to the paste, boop, boop, and we get a z-score of negative 1.28. Okay, everybody see? Everybody get that? So what popped out of my calculator was negative 1.28. Okay, and remember, z-scores always have 2 decimals, so you want to round that to 2 decimals. And again, do not leave your answer like this. This doesn't mean anything to anybody. So what we would do is we come back over here and we say the z-score is equal to negative 1.28. That is that z-score right there. Okay. So let's see what happens if we look at one that's not set up perfectly. Oh, actually, we're still going to look at one that's set up the same way. All right. So this says find z if a left tail is 75% of the graph. Okay, so the thing that's nice about this one is that it says left tail, and we're also always supposed to think left tail. So we're set up in that sense really nicely. The thing that's not so nice is they didn't give us a graph. So if we want to draw a graph, we got to be very clear here. So when it says the left tail is 75% of the graph, that means that we're going to be shading the graph from the left tail, and we're going to go 75% of the graph. Now, here's the middle. So if we go to the middle and shade to the middle, are we at 75% yet? We're not, are we? We're at 50%. So we need to go a little further. Maybe we'll say like that's the boundary. So across the middle would be 75%. So we look at that and we go, does it look like we have more than 50% of the graph shaded? Yes, we do. We have 75%. Now, the other thing to keep in mind here is that they gave it to us in percent form, but in order to use our calculator, we need to note that this is an area of 0.75. Don't put in 75, put 0.75. So again, you're going to go to your inverse norm. So inverse norm, and we're going to put 0.75, and we'll see what pops up. I got 0.67. Now remember, this is not an area, this is a z-score, so we only want the 2 decimals. So we get a z of 0.67. Okay, and there is our answer. Okay, so what happens when we're not given that left tail though? Let's look at a right tail. So let's say that we have this. So they give us this graph, and there's the middle. They give us this shaded area, and they tell us that this area is equal to 0.05. 0.05. Now, this is a right tail, not a left tail. So there's 2 ways to do this. I like to keep things kind of always thinking towards in the right direction. I don't want to like turn things around. So I want it to, the graph to stay like this. So what we want, if we want to think of left tail, we want to think of the left tail going this way that corresponds with a right tail of 0.05. So what I mean by that is if you know that this is 0.05 or 5% of the graph, then what's this? Okay. Would you agree that this is going to be 0.95 or 95% of the graph? If that's 5%, this is 95, right? And that is using the complement. So when you're given a right tail of 0.05, what we want to do is think about the complement and use the complement instead. So we're going to go with an inverse norm of 0.95 instead of the 0.05. So inverse norm, 0.95, right? 0.95, boom. And I get an answer of 1.64. All right, now a little bit of a quirk with this guy. This 95% and 5%, it shows up a lot. So we've got to get used to it. And it shows up so much, and it has shown up so much through history that this is a z-score that gets used and has been used for all time. And here's the little issue. Back, years ago before we had our nice calculator to do all the calculations, when you would do this calculation by hand and find that area, the calculation actually rounded to 1.65. Now that we have the calculator and it's, precise to so many decimal places and everything, the calculator did give us 1.64, didn't it? But it's almost 1.65, it's very close. But because this guy is used so often and for so many years, we tend to use this instead. So I want you to get, even though the calculator tells you 1.64, and I won't mark you wrong for that, I want you to be able to see the 1.65 and know that that goes with the 5% tail. 1.65, 5% tail. Okay? So this you see more often than this guy. So we want to get into the habit of just going with the flow. So this is one of those times where, because the statisticians have been doing it forever, we just finally go, okay, whatever they want to do, that's good. So that's where the 1.65 comes from. So if you're looking in the book or someone's talking about this number and you go, wait a minute, my calculator says 1.64, that's the reasoning behind this. It's so used over, decades and decades and decades that this is just kind of the standard that we go to. Okay, so remember, when it's backwards, you use the complement, right? Use the complement. And then we have one more situation. Okay, so this one says, find the z-scores that bound the middle 95%. Okay, so this is different than the last one because this one says find the z-scores that bound the middle 95%. So when we draw this one in here, middle means middle. And statisticians, when they say middle, you can always assume that it's symmetrical. Okay, you can always assume symmetry here. So when it says middle, you can assume symmetry. So there's no tail at all in this one. And if there's no tail at all, well, we can't use our inverse norm. So we need to fiddle with this a little bit to figure out what the area of this tail would be. This is the guy we want because that's the left tail. We don't want this one, we want that guy. So what we're gonna do is fiddle with this 95% a little bit. So if this whole thing is 95% and it's symmetrical, doesn't that mean we can divide in two and figure out that this is 0.475 or 47.5%? Okay, so we take the 95, we divide it by 2. Okay. Then if this is 0.475, but this whole half is 0.5, what's left over here? So could we go 0.5 minus the 0.475? And would that give us 0.025? So this area that we have here ends up being 0.025. Right? Another way to do this would be to take this 95% and find the complement of it. If this is 95%, there's 5% left over. But half of that is on one side and half of that is on the other side. So if there's 5% left over, then we divide that in 2 and we still end up with 2.5% or 0.025. So either way you go about it, it takes a little bit of math to figure that out, and that's why the visual is helpful. So you draw it out, and remember, we don't want any of this, we need a left tail. So we're gonna go inverse norm, and we're going to use the 0.025. And when we do that, 0.025. Enter. And here I get negative 1.96. Everybody agree if we round negative 1.96? And that gives us this z-score. But the thing to remember is if life is symmetrical here and that z-score is a negative 1.96, what's this z-score going to be? it should be a positive 1.96. So z equals positive 1.96. So we end up with 2 z-scores. And again, symmetry, so everything is the same, but the way the calculator works is always by using a left tail on the inverse norm. All right, so that's an introduction to the normal distribution, okay? So the idea in this section is just to learn to use your calculator, practice, 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 and then once we get into the next section, it's time for word problems like how the heck are we actually going to use this? Okay, so that's what we will do. All right, bye.